Hi there. Welcome to the Productive AI podcast. I'm your host, Troy Agredon, and today I'm joined by Eric Law from Urban Machine. And Eric and I are going to talk about the mission that their company is on to reclaim half of the 37 million tons of wood waste that goes to landfill in the United States every year by turning it into premium lumber. Eric, welcome to the show.
Absolutely. Thank you, Troy, for having me.
You bet. Been looking forward to this conversation. And actually, as you and I discussed before this, I seem to be on a trend. I'm going to be doing probably a whole series on construction and robots and industrial AI and things like that. So pretty excited about having this conversation. So why don't we do this? Why don't we start with, if you could give a little bit of background on yourself, sort of where you came from before you got to this company, and then kind of how you ended up building this team and building this company. That would be a great place to start.
Yeah, absolutely. So I've got about a 20-year career of, call it a maze path of technology, construction, merging the two together. Actually started in a SaaS company in 2006, sold that in 2015, Bentley Systems, and then built an innovation program for a large general contractor. And while I was building that innovation program and bringing robotics into construction to solve the labor shortage, started doing research into sustainability. That's where I learned about the wood waste problem. That concrete and steel both have recycled paths, but unfortunately wood waste was heading to landfills because of the metal fastener. It's just too labor intensive to get the metal out without destroying the wood. Or if you put humans on it, it becomes a very high premium piece of wood. It's a very niche market today. And so that's where I connected up with Andrew Gillies. He and I had worked on some other construction robotic research projects. But hey, could we automate this? Our robotics testing. He's like, absolutely. And then we brought on Alex Steele, who's a computer vision AI expert that Andrew had worked with before. And that was about a year and a half ago. And then off we went, raised a couple rounds of funds now and proving out the technology, getting ready to release our first product here in the next couple months.
Awesome. When you were looking at the space, you said you were sort of already kind of in that environment. You were looking at, there was an existing wood waste problem. So just tell me more about that. What was the situation?
Yes. And so at the general contractor, we were researching, how do we become a more sustainable contractor? And in construction, waste is a major environmental problem, predominantly in the US because our building owners don't like to keep their buildings. They always want, that's everything from remodeling them every 2 to 5 years for an office building to tear downs every 30 to 50 years. US have a real habit of tearing down our infrastructure, and that generates a lot of waste. And so we're looking at, what are those volumes and where does that material go? And concrete and steel, concrete gets ground up, becomes base rock for another project, a little downcycled, but at least it's not going on landfill. Steel heads back to the smelters and gets melted down into new products. Yeah, it takes a lot of energy, but again, not to the landfill. But wood was going to landfills and incinerators. And what's unique about wood is the material that came from our forests, 50 to 100 plus years ago was incredibly high quality, right? Real tight grains, very few knots, had been growing for hundreds of years before humans took it down. And we don't have access to that material anymore. So it's a scarce resource. The lumber we get from our forest today is all coming from farms, 30 to 40 years, typical life cycle for a farm tree. And so it's, big grains, quick growing, lots of knots, your standard issue you find at your lumberyard. And with wood, once you get the metal out, it's as good as it was when it was brand new from the mill. A little bit drier, a little harder. Don't try and hand pound a nail into it. But it's a real high quality material. You don't have to melt it down. You don't have to grind it. You can use it as is. And so it's a big waste for us to just throw this away. And to put that 37 million tons in perspective, it's equal to about half of what we log from our softwood forests every year here in the United States. So every year we go to our forests, we log all these billions of board feet, and half of it we throw into a landfill. Not sustainable.
That's incredible.
Close, right? I mean, it's just massive. And here in the US, we're one of the largest users of wood products, and we actually import more. So our forests generate a ton of material, and then we still have to import more from Canada and other countries around the world. And wood is a great product because of its carbon benefits. It's beautiful. It's got architectural value to it, not just structural, it stores carbon. And so throwing this away or burning it is just not the right route for it. And so we're kind of at an inflection point where the technology costs have come down and the capabilities are available to automate this problem. So we can use it again. So it's a lot of fun when you get to apply technology to an old problem. And then the output is a really sustainable, high quality built-in product.
I think everybody's probably heard of what are the industry terms? Reused, not reconditioned. I think there are some general industry terms for sort of reclaimed lumber, right?
You got reused, reclaimed, salvaged. So usually reclaimed and salvaged are kind of the two ones. Reclaimed is a little bit of a nicer word. Some people hear the word salvaged, then go into a dumpster and find it.
Yeah, right.
So we've been using, reclaimed lumber is kind of the predominant industry term for it.
Okay. And what's the standard for that? It's just, as you said, it's very labor intensive because you're literally pulling these nails out by hand, and it's just costs a lot to reclaim it. Is that the problem?
Exactly. So the current state of the industry is they're probably reclaiming about 1% of all the board footage out there that comes out of buildings, and they're really targeting kind of premium buildings. So think about your really old barns with that nice patinaed wood, or your really large beams and really old military barracks, stuff like that, really niche buildings where they can sell that wood for, $20, $30, $40 a board foot, right? Really premium, super premium products. So they can justify the labor to go in and pull out the bolts and the nails and the metal that's in it before they cut them up and use them in those buildings.
How does that compare to just kind of market price for lumber? So you said 20, what do you say? 30 to $40?
Yeah, you're looking at $20 to $40 a board foot for that type of stuff, right? And when you look at, commodity lumber today, it's back down to its lows of, you're looking at 35 cents to $1 a board foot, depending on your cross section.
Oh, wow.
Yeah. So you're paying a 20 to 40x premium for this, right? But you can't get it. And, there's actually some YouTube videos that we've come across of people taking virgin lumber and trying to make it look like reclaim.
If they're going to charge 20 to 40 times more, I can see why.
Exactly, right? And it's
wait, is there fake reclaimed lumber then, basically? Are people trying to pretend it's reclaimed when it's
absolutely
not, just because they can get higher price?
You can go to your major furniture stores and they have all these beaten up looking furniture where they took virgin lumber and beat it up with a process to make it look old. And it's like, wait, so we're throwing away the stuff that already does this, and then we're converting the new stuff to this? It's just, you got to be kidding me. It's just like jeans, right? Jeans, they sell them with the holes in them today for more than without it. And it's like, wait,
those are $400 jeans if they got holes and they're all worn. Okay, so retail, just off the shelf, new lumber, but something around $1 a foot, and then 20 to 40 bucks a foot for this kind of reclaimed, because it's so expensive to reclaim it. So what was your big sort of aha? What happened as you looked at that? And obviously it sounds like that was the genesis moment for the company.
Yeah. So a couple things. One, it checked the box of it. It's a massive problem.
Sure.
There's a lot of raw material out there available to us. The second one was the technology, right? Can we do this and automate this and bring down that cost of process? And so we checked that box. We've actually proven out that we can automatically clean up lumber. And now we're going after the box that says, can we do it at scale? Right? How fast can we do this? This is the one that we're working on. And so our first production unit will be proving that here in the field in a couple of months. And the other box is, is there a market for this? Right? If we take and generate substantial volumes of material that nobody's seen in the reclaim market, what's going to happen to it? Do we flood it and the price comes down to virgin? That makes it quite attractive because now we can compete with virgin lumber. Right? And so that's what our business plan is based on, is generating enormous volumes of reclaimed lumber. And the cool thing about lumber is any existing wood manufacturer that accepts virgin can process reclaimed. Once the metal's out of it, you can cut it, you can mill it, you can rip it, you can do all your same activities to reclaim that you do to virgin. The big advantage is it's a more stable product, been drying straight in place for 40, 50, 100 years, depending on the building. Very low moisture content, very high quality material. And so there's a lot of people that are very interested. They're like, wow, we can do this and we can feed it into the existing workflow. Right? I'm not changing a lumber manufacturer's workflow process. I'm just giving them truckloads of material. And that's been the real holdback to a lot of manufacturers processing reclaim, right? They're like, hey, can I order, 100 truckloads and you're going to send me a truckload a day to feed my fab line? Historically, no, right? There's no capability. And we want to become that provider that enables that with our technology, where we can send them a truckload a day of reclaimed 2x4s coming out of apartment buildings or low-rise commercial buildings, and just feeding that directly to these guys, and they're building all kinds of products with it. And that can be everything from architectural stuff to think about like engineered products like glulam and CLT are great uses for this material.
And so currently today, what does it look like? You basically have all of these large construction projects, which are really renovations or teardowns or whatever they are. these folks are going in, is it the construction company? Who is going in and tearing this stuff apart, and where are they sending it today? You said they're sending it to landfill, right?
Yeah. So typically a demolition contractor is responsible for taking down that building or gutting the building or whatever the scope of work is that needs to come out. They hire a demo contractor, and then they're responsible for disposing of the materials. So typically, if you take like a 1960s warehouse that's coming down in a metropolitan area, because maybe it's 1 or 2 stories and they want to go put in a 20-story apartment building. Very common situation across the country, right? And so they go take that building down, they put the concrete in a pile, they put the steel in a pile, and then they put the wood and everything else in another pile, and they grind it all up. And when they grind it all up, depending on the content of that pile, if it's pure wood, they can send it off to an incinerator. Maybe they send it off to a C&D facility who turns some of it into some landscape, or it goes to alternative daily cover. And so the C&D facilities will process that material, and then they'll separate it off that says, hey, look, this is wood with some plastics and some drywall and some glass in it. It's going to the landfill. We're going to use it for alternative daily cover. If it's pure wood, then you can do the landscape mulches with it, or the incinerators will take it. Many of those incinerators are really cogen plants, so they generate electricity by burning the wood. A lot of those guys are shutting down because of the solar. Solar electricity is so cheap to operate, the cogen plant guys can't compete on a per kilowatt basis. And so that's becoming less of an option. So really it's landscape mulch and landfills.
Well, and not to mention the carbon.
Yes. And all that carbon just got released into the air, right? If you're carbon counting and you send this to a cogen plant, poof.
I mean, they're probably I'm assuming those cogen plants have had to do some serious carbon capture on them. So if they have done that, then it's probably taken care of. But if they haven't, I'm surprised they're allowed to operate, frankly.
Yeah, well, I mean, mostly across the country, there's very low regulation on carbon, right? It's all air emissions. And so it's more on the pollutants, right? Capturing the particulates, capturing any hazardous materials. Nobody's worried about CO2 coming out their stack.
Oh, okay. Got it.
Right?
Or on just the pure pollutants.
Pollutants is what everybody's targeted. So most of those guys are just, the CO2 is coming straight out.
So these guys are separating out all the wood into these various different streams and then sending them off to those various places. And I'm assuming that 1, it's costing them to do the separation, which they have to do probably. And then 2, it's probably costing them to send to each of those different streams, or maybe they're getting paid back on some of those streams, or how does that work? What are the economics there?
Typically the demo contractors are paying $100, $150 a ton to dispose of the material.
Okay. So it's a cost to them. It's not a revenue source to them.
Exactly. They'll get some revenue maybe on the steel, depending on scrap values.
Okay.
Maybe on the concrete, again, depending on the scrap values or the base rock material. But for the wood and the plastics and the glasses and all those other materials, it is straight up expense. It's trucking expense. It's tipping fees to get it off their sites.
So they're literally being paid to tear this thing down and get it out of here. And then they have downstream costs to dispose of all of that material.
You got it.
Yeah. Now, what's your kind of business model here? Are you suggesting that, they pay you instead, or do you pay them, or how are you thinking about that?
Yeah. So what we've designed it is we're going to them and saying, hey, look, guys, we're going to take this material off your hands at no cost.
Nice.
Because what we want to do is we want to incentivize them not to smash it up. Because one of the challenges we have is typically they take down buildings with excavators, and excavators are not a friendly tool. If you're taking down concrete and steel, who cares? It's getting ground up and melted down, right?
Sure.
We won't care what it looks like. But wood, we don't want them to turn it into toothpicks. Because once they curate into toothpicks, I can't do much with it.
Got it.
And so we're trying to give them an economic incentive to maximize the value. And so if previously they're doing $100, $150 a ton plus trucking, and we're like coming out of them and says, hey, don't spend that money. Just give us a big pile on your job site. We're going to come clean it and process it and take it off your hands. Then the demo contractors can say, oh, let's take this building down a little bit differently. Maximize the wood that goes to urban machine, because then it doesn't go on our tipping bucket. Less fees for us.
So there's a process change on their side. It's not just, hey, you're not going to have to pay to dispose of this. They're going to have to think about how to take it down and keep as much of that wood intact as possible, which they weren't doing before. So the incentive has to be enough to not just cover, hey, you don't have to pay for the disposal cost, but to pay for the extra labor for them to take it down more adequately so that it's still stock for you.
Exactly.
Okay.
And when we talk to the demo contractors, they're like, that's what's missing today. There's no economic incentive for us not to smash this up, right? Market for anybody to take the material off their hands. And so we want to create that economic incentive and create that market and create that demand for it. That's really our goal. Is we've got this technology. We're creating a demand for this material, And then we'll create the supply into wood manufacturers and companies that can consume it.
Okay, so you get this material ideally for free from this demolition company. They give it to you. Hopefully it's all intact. It's not a bunch of toothpicks, as you said. So it's usable for you as feedstock. You put it into the system. It outputs essentially new virgin lumber out the other side. Are you able to share what either your actual or your target kind of price is on that lumber? Because it sounds like you're turning around and reselling that to projects.
Yep. Yeah. So our goal is to get down to virgin, right? We want
to $1 a foot or somewhere in there.
Exactly. That's where we want to be, right? We don't want to be at $20 to $40 because there's just not enough demand for that. We got to get ourselves down to that $1 a board foot, somewhere around that area, depending on the cross section. But so that's our target. Those are the metrics myself and the engineering team have for our technology, and we believe we can do it. With this first system come out in the field, it's going to be our opportunity to go prove it, because our systems are going to move about 16,000 board feet a day, depending on the material, what the feedstock is. That's equivalent to about a single family home, about a single truckload of materials, about 16,000 board feet of dimensional lumber.
Okay. It seems like, though, if the market is currently pricing that reclaimed lumber at 20 to 40x, right? $20 to $40 per foot, that even if you could come into the market consistently at $10 or pick a number, something between 20 and 1, that you could probably get rid of that stock all day long, right? If you were somewhere between those two numbers.
Exactly. Well, it depends. So if you look at 20 to 40, that's pretty premium stuff, right? That's your barnwood, super nice stuff, right? So ours doesn't quite check that box. But if we get down to the virgin and it's a client that's counting carbon, right? Because one of the big challenges with virgin lumber is the energy footprint is 90+% compared to reclaim. So it takes 90% less energy for us to reclaim a board foot of material than it does for virgin, because ours is already dry, right? I don't need to fire up a kiln and dry this for days by the train load. Our stuff is dry and straight and ready to go. So for those that are looking for a premium product, much smaller carbon footprint, like they say, the best product to select is one that already exists.
Yeah.
Right. Don't go make something new. Don't go build a new product. Use one that already exists. That's a huge carbon reduction in your embodied carbon for your building. If you're using reclaimed lumber, it's a dramatic reduction in the transportation carbon because it's locally sourced. Right. We're not trucking it or training it thousands of miles to get it to the customer. It's already typically in that metropolitan area, and it's already cut to shape. Right. I don't have to dry it. I don't have to replane it or mill it. Typically, they're already the right dimension. And then if you want, we can clean it up a little bit, but it's locally done.
And are they already factoring carbon into their businesses? No, I'm talking the construction company that's taking this in to build a new project.
So some are. Very few of the contractors. It's typically the owners. So all the owners that have, carbon goal of net neutrality by 2030, 2035, if they're doing it correctly and they're looking at their total carbon footprint, they have to look at the carbon in building those buildings. Can't just look at the carbon to operate them, right? To heat them and cool them on an annual basis. You have to look at your full carbon footprint. And there's a lot of owners starting to do that. They're starting to wake up and say, okay, I can offset my operational carbon for my heating and cooling and lighting loads. But what about the debt I have from building this building? And if you built a big concrete
full life cycle,
exactly, that debt is massive.
Right.
Typically, often it's in the operational carbon and the life cycle of that building.
So how hard is it to build robots to strip nails out of lumber? Because that seems like a pretty gnarly problem. I would love to hear about your whole journey here, because that seems like a really tough problem.
It is. The nice thing about it is it's easier than sorting garbage. There's a whole bunch of robotics companies out there that are trying to sort vegetables and garbage and do all that. Because, there's only so many types of nails, screws, and fasteners, right? If you look at like a municipal waste stream compared to what we're doing. So our problem's easier than that. It's still incredibly hard.
Interesting.
It's still a really hard problem. But the nice part about it is the consistency of the fasteners coming through. They change a little bit with the age of the industry.
Sure.
Before 1980, we don't see much for screws, right? Because they really didn't start showing up until the 80s and 90s. But 16 penny nail, we're seeing millions of those, right? They're bent over in different directions and they're all smashed or they're straight or they're crooked, whatever. But that's just a training algorithm problem. And so it's really us just building our data set and training these machines on how to respond to those different orientations. And then we built all of our own end effectors because the existing off-the-shelf ones weren't going to hit the unit economics in terms of speed and performance.
Sorry, say that again. You built our own
robotic arms.
Okay.
So all the arms,
wow.
More videos, those are all built by our engineering team, designed and built by our engineering team.
With all the robotics, the industrial robotics that are around from Fanuc or any, name your top 10 robotic suppliers in the world, particularly probably automotive, I would think, or industrial. None of those were suitable?
No, because they're massive, right? In order for them to get their massive strength, their big arms, because they're used to picking up a car or a tire or that, and they're used to, hey, let's go move the tire around in 3 dimensions, 6 axes. We didn't.
Yeah. Okay.
We just needed strength in a single axis. And then, the other side of the spectrum is you got the microchip folks, right? Really high speed, low weight, incredibly fast arms, moving that. We had to merge those two together. And you get the strength in a single axis of a big industrial. Yeah, I want the speed of semiconductor lines. And so we looked at those two kind of for inspiration and ideas, and ours is a combination of those two. It's the best of both worlds. So we get the strength and the axis we need to pull a 16 penny down. Our arms are pulling, 700 to 1,000 pounds of pull force to get a nail out, but they're moving with the speed of a microprocessor line.
Okay, so give everybody some context. How big is this machine, and how big can a piece of wood be that comes through this machine?
Yeah, so the machine is 80 feet long. Is our process line.
Oh, yeah, this is a big operation then.
It's a big operation, but we're not building cars.
Yeah.
Right. So we're kind of somewhere in the middle, right? So it's an 80-foot long process line. It rides on 2 40-foot trailers.
All right.
Portable. So we can go out to the job site and clean on the job site, which is beautiful because then we can ship on flatbeds coming out of there. And within this line, we've got brushes, we've got pullers, we've got x-rays, we've got metal detectors. There's multiple steps to getting this thing clean at the end and saying, hey, dear customer, this is metal-free wood, right? There's a whole lot of steps it's got to go through. But it's awesome to see the material run through it. And we can process everything from, a 2x4 cross section, so 1.5 inches, 3.5, on up to 6x18. And the pieces can be 6 feet long on up to 40 feet long. So we can run a massive timber beam through our system or a big glulam beam through our system and take all the metal out of it and then ship it off to a customer.
That's incredible. So theoretically, you could say to a customer, hey, carve off this much space in your site and just pile all the wood there. And then your team could take a look at that wood and say, yeah, this thing's suitable. It's feedstock. Put it in this feedstock pile. And then that could go into the system. And at the other end, they're going to get basically virgin lumber.
Exactly.
Which they can reuse or you could ship off.
Exactly. It's up to the customer. We love the customers that want to reuse it on the new project, right? That really closes that loop. Take down the old building, put it into the new building. And the cool part too is technology is allowing us to tell that story. We can print a QR code on it that came out that said, hey, this wood came from this building that you tore down. Now in this building, here's the process it went through to get from the old building to the new one. And imagine somebody walking through their condo and they see a QR code on the wood column and they hit it and it says, hey, this column came from an old cannery or something down the street where this building material was.
Wow. So what is the stage of the robots today? How many do you have? And what's the stage of the company? Where are you at overall?
Yeah. So we've finished 3 prototypes. So we've iterated 3 times. We're building our 4th iteration right now. And this is the one that'll go to the field. So this 4th iteration that's getting fab on the wall behind me here is going to be those 2 40-foot trailers with all these different systems on it. I'm going to go start cleaning lumber. And we're probably about 2 months away from those rolling out of the shop here and going to their first projects. And so we've got a lumber yard that we partnered up with. We've been stockpiling truckloads of material to use for testing. And it's going to test in the shop. It's going to go test there. And then hopefully this summer we'll be out some job sites rolling around here in Northern California cleaning lumber.
That was going to be my next question. You guys are based where?
Oakland? We're based in Oakland, California.
Okay. So given that it's on 2 flatbed trucks, I'm sure, and there's tons of construction all over the East Bay, all over basically the Bay Area, are you going to just kind of start working in kind of concentric circles and work your way out? Because it seems like obviously that would be most efficient by the right customer.
Yep. So we're lining up pilot projects with both demo contractors and then also with C&D facilities, right? Those collection points.
You mentioned C&D earlier. So C&D stands for what?
Construction and demolition.
Oh, got
it. They're the ones that final contractor, and all I want to do is fill up my pickup truck. I go drive there and they take it from me. And then they sort it and grind it or do whatever they're going to do with it.
Got it. Okay. So this is version 4. Okay. Do you name these robots? I'm always curious if people are going to name their robots.
We do. We actually have an internal name.
Excellent. Anything you can share?
Yeah. So this one's Brave Baobab.
I love it. That's excellent. So version 4, Brave, is going to be ready in a couple of months. And then hopefully you'll look for some sites. What are the kind of sites that are a really good fit for this? Like what size or scale? I imagine they have to have a certain amount of scale for this to make sense.
Yeah. So for us to roll on site, bringing 240-foot trailers, trucks, and infrastructure to go with it, typically we're looking at, 50 to 100,000 square foot buildings, typically commercial warehouses, office buildings with wood frames in them or wood roofing at least. Okay. Because we want to process somewhere between 50 and 100,000 board feet, kind of as our minimum range to roll out there. Mm-hmm. So it's not a single family house, right? So the house is about 16 to 20,000 board feet dimensional.
Got it.
But, if you're taking down an apartment building, if you're taking down a warehouse, office building, a lot of offices built in the 70s and 80s use timber, use glue lamps, especially in the 80s, a lot of glue lamp. And so that's a great opportunity to reclaim that.
And based on your earlier comment about the demolition companies and some types of buildings that are a best fit for that, where they're like, yeah, this makes sense. We can get this out safely and economically. And so it's worth it for us to not pay the waste removal fee and to have people pulling that out. Is that what you're kind of describing? More of these like warehouses and things like that would probably be a really good fit for that.
Yeah. Commercial warehouses are great because usually they're open beam ceilings and what, right?
That's what I was thinking.
Single level, double level. The toughest ones are probably your apartment buildings where you got drywall and glass and plastics and everything covering the wood.
That's what I was thinking because that's probably easier to just knock it down with an excavator.
Yeah. And historically, we are doing some test projects with some of our demolition partners to look at how can we harvest those buildings, right? Okay. How do we keep the excavator in play, but maybe put a different tool on it instead of the bucket with the thumb that just crushes everything.
Yeah. But in terms of sequencing things, it sounds like, sure, if you could get just an all wood 2-floor warehouse and they could push it over and not smash it over, that would probably be easiest for you to pull that out safely and economically, or for the demolition company to pull it out.
Absolutely. And the demo guys are like, sometimes the cost for us to deconstruct one of those warehouses where it's all wood is the same cost to smash it down. So
is the same cost?
They're like, we can do it the same with our equipment because they have full access to it.
Okay.
Right. They're like, it doesn't cost us any more to give you all the wood out of these, whereas like an apartment building, it's going to take them a lot more effort to get the wood out.
Oh, I see what you're saying. Yeah. Yeah. I was thinking in all cases, it would probably be more expensive for them to take it out intact than it would be for them to just destroy it, basically.
So yeah, no, from opportunities, it's almost the same.
Okay. And then where does this go from here? What's the general trajectories you look forward here? Obviously, you'll get version 4 out. You'll be running around looking for these sites, and then sounds like really proving it out and proving both the mechanics, the operations, and the robotics side of it, as well as proving the value side of it. And then what?
Exactly. And then let's go try this in different markets. So our goal is to get 2 systems here in Northern California here by the end of this year.
Okay.
And then prove that. And then next year is, okay, we did it in Northern California. Let's go do it in Seattle. Let's go do it in Denver. Go do it in Chicago. Try it in 6 different markets. Machines, put 2 in each market to demonstrate that says, hey, this isn't just a one-off to green Northern California. Let's go do this in Texas, right? Let's go down to Austin, San Antonio and go prove it out down there. And then once that box is checked, all right, we can do this anywhere in the country. Pretty sure we can do this around the globe. Let's go start building 6,000 of these things.
That's awesome.
It's going to take 6,000 of these systems running around the country to get that 50% of 37 million tons.
Wow.
Yeah, it
is. That's a huge vision. That's really awesome.
Right. Our challenge is going to change from, okay, here we are proving this technology and economics on 1 to 2 systems.
Yeah.
And then it becomes a whole mass manufacturing problem. Right. We get to go do what Tesla did, except for my machines are 80 feet long. This isn't a little 16-foot.
It's more like a Tesla truck, actually.
Exactly.
Although actually they're simpler.
With the trailer, and I got 2 of them, and it's 50,000 pounds of equipment rolling down the road.
Right.
To go clean this material. So it's going to be fun.
Wow. What a riot. Okay. So then where are you guys in terms of what are you looking for next, right? As you're going up this curve, as you're working through this process, I'm assuming you're looking for talent. I'm assuming you're looking for clients. Tell me about some of that.
Yeah. So like most startups, we're out there looking for mechanical engineers, software engineers with that robotics background, okay, which is actually a niche in the world, right? There aren't a lot of people that go into robotics. There's a bunch in the auto industry and stuff. But yeah, we're looking for mechanical engineers and software engineers on our team. And then we're looking for those early adopters, right? The customers are like, hey, I'm taking down a building. I want to reuse this building. I want to reuse this. I want to work with Urban Machine. I want the story. I want the carbon benefit. I want to do good for the planet and good for economics, right? A lot of these projects, if we can source the right material from their existing buildings, they're going to save money on it.
Yeah.
Because they get this high quality material and the new one, get a great story to go with it.
All right. So we talked about the clients, potential engineers, the talent. Let's just do the quick wrap up on the advice.
So yeah, advice for future entrepreneurs taking on this problem, right? Yeah. It's build a good team. I would say that's the most important thing, right? You need co-founders. This is not a problem you can go do on your own. And it's not just co-founders, but you need good investors along with you. Robotics is expensive. My last company was a SaaS one. Yeah. The capital costs of that were just tiny fraction.
So much different.
Right?
Who are your current investors, if you don't mind sharing that?
Yeah. So we've got Lower Carbon Capital, GV, Union Labs, and Catapult. The 4 VC funds on board, and a couple small angels to go with it.
That's great.
So they're great partners to have on board, and they're much more than just a check. Yeah. This is a group of folks that are bringing expertise. They bring customers. They bring early adopters. They know how to help startups succeed. And so it's a large effort, right? When you're talking large problems, to be a single entrepreneur, just try to do this on your own, that's pretty hard.
Yeah.
Could be doable, but it's going to be pretty tight up, right? And then build a network of folks around you. We've got advisors and customer partners on lumber yards and manufacturers that we're working with and designers that are all super eager to support this mission and help make it successful. Because, there's technically solving the problem, but then there's bringing it to market.
Yeah.
And that's typically the hard part, is getting to the market, feeding into the supply chains, getting the people on board to buy the product from you, source the material to you, and make sure you have domain expertise. I've got my construction background. I've got Andrew and Alex with their robotics and hardware and software backgrounds.
Right.
So merge technical with domain expertise. Mm-hmm. When I was working at the large contractor, we'd see a lot of startups that were one or the other. It would be technical team with no domain expertise.
Yeah.
And we'd just be like, we're going to these folks. Yeah, you guys are super smart, but you have no idea how to fit into the ecosystem.
Yeah.
And so we'd match them with our job sites and superintendents and say, here's how you're going to work. And their eyeballs popped out of their head. They're like, really? This is what you guys do? Yeah, this is what we do on a job site. And then you have the folks with no technical talent that were struggling, because if you don't have technical co-founders, it's real expensive to hire.
Yeah.
So the biggest advice is just team. Right? Build yourself a team. And that's really, when you're starting these ventures, is raising folks to come join you on your mission. Our mission is salvaging the past to build the future with technology.
And that's such a good tagline. And it's a good mission. And it's an easy mission for, I think, everybody to get on board with. You're going to run into a lot of folks that, whether they want to come to it from the environmental side, the ESG side, there are a variety of angles that would drive them to say, I want to be a part of this team. I want to support this mission. So yeah, I love that focus. And your team is, as you said, that extends. That's not your core team. That's your core team plus your advisors, plus your investor partners, and all of them aligned on that one mission, which is really great.
Yep.
Excellent. Last quick question for you. I think you guys are just about to start your first live stream. Tell me about that, and then we'll wrap it there.
Yeah. So,
you guys are going to be a media company now.
Start up for roller coaster rides, right? You gotta have, the thick skin, because you're going to have awesome days, and you're going to have days where stuff breaks. Really expensive stuff breaks. And so when Jory joined the team, she started hearing the stories about, hey, this 40-yard dump truck launched wood and it broke a prototype. Right. The day the circuit board caught fire in the shop, right? And the teams, we just had a new one last week. One of our machines just tried to drive off the tracks.
Oh no.
And so she's like, we got to share this. We got to tell people about what really goes on behind the scenes here at startup. And so she came up with this idea for this podcast. And so she's going to start interviewing our engineers and talking about these events and really kind of showing what goes on in a startup. Because a lot of people just see on the outside, oh, this startup's successful, they grow, and they see the good side. There's a lot of stuff that goes on behind these walls that you're like, oh, well, that was a crappy day. All right, let's keep going, right?
Yeah. What's the name of the live stream?
Once Upon a Time.
Okay. And then you're going to be publishing that starting next week?
Oh, This One Time. Sorry. Yeah, This One Time is what it's called.
Okay.
And we're going to start, I think the first one will roll out in the next 1 to 2 weeks.
Okay. That's awesome. So essentially, horror stories behind the scenes of a startup. I think that's going to be awesome. Actually, it's probably going to be a really fun way for you to essentially build your reputation and outreach to the technical audience you're looking, right? We have mechanical engineers, hardware, software engineers, because they're going to be like, these folks are building real stuff. They're solving and running into really great technical, fun, hard technical challenges. So it's going to be a great tool for recruiting, and it'll probably be really funny and great for just brand development. I think it's going to be awesome.
Absolutely. And it also shows, not just solving problems, but, how do you adapt and change?
Yeah.
Right. Every time you find a problem, the key thing in a startup is you can't repeat the same problem, right? You got to learn from each one. You got to adjust, and that's how we came up with the portable machines. Well, like we can't have dump trucks dumping material. It destroys the material. It goes everywhere. It breaks stuff. It becomes a much harder problem. So let's go portable, right? Not major change, right? Instead of going with manufacturing plants to trailer-based systems.
Right.
It was a pretty big pivot, but it's one that's going to pay off and make us much more efficient, reduce our costs.
That's awesome. Eric, thanks so much for doing the podcast today. This has been awesome. I'm so excited for you and the team and really appreciate that Troy had reached out and connected us to do the podcast today. So wish you guys the best of luck and we'll be following you closely.
Absolutely. Thank you very much, Troy. It's been a pleasure meeting with you.
You bet. So for everybody watching and listening, thanks very much. This has been another episode of Productive AI Podcast, obviously, with Eric Law from Urban Machine. I'll put some details in the show notes so you can find Eric. Eric, I'm assuming it's just the best way to reach out is email and or LinkedIn, the places you hang out the most.
Yep. Well, that's where I am.
I'll put those in the show notes for anybody who wants to connect. Excellent. Thanks very much and see you on the next episode.